Hi children, good morning. So I'm Vikramaditya here, and we're going to discuss about the concept of motion today. Okay, so we are all familiar with idea of motion, right? So any object which is moving from one place to another place, we can call it as in motion. So we see several examples of motion around us, like motion of people, like people moving from here and there. You go to school, come back. This is all motion, right? And vehicles, trains, aeroplanes, birds, raindrops, objects thrown into air. So we know that it is all due to the motion of the earth. That phenomenon, we know that it is due to the motion of the earth that phenomena like sunrise, sunset, changes in the season, etc. occur. Now if earth is in motion, why don't we directly perceive the motion of the earth? Means, like, why can't we see the earth moving? We all know earth is moving, but we can't see that earth is moving, right? So why do we do that? And why is it so? Okay, we need to understand that. Or are the walls of our classroom at rest or in motion? That you need to say me the answer. So are they in the motion, or are they still? Have you ever experienced that in the train in which you sit appears to move when it is at rest? Why is it so? To give all the answers of these questions, children, we need to understand the terms relative and motion. Relative and motion, two things. It's not just about motion, it's also about relativity. So great progress in understanding motion occurred when Galileo undertook his study of rolling balls on inclined planes. Now, when the inclined plane, a slanting one, right? So on that, if you leave a ball, what happens? It rolls down. To understand the motion, we need to understand the meaning of the word relative, which plays an important role in explaining the motion. What is relative is what we need to understand. So we use many statements in our daily life to express our views. The meaning of a statement depends on the context in which it is made. Does every statement have a meaning? Evidently no. So even if it is perfectly sensible, grammatically correct, and everything is perfect, but it still doesn't make any sense. Let's take an example of a statement called this water is triangular. The water is triangular, so there's no meaning of what this water is triangular. Okay, can hardly be given any meaning. Okay, let's take another example of this. Let's take a grammatically perfect statement but does not make any sense. Okay, take an example of your friend. Okay, just tell me your friend's name. Think of your friend's name, and you're saying that I'm drinking my friend. So you cannot drink your friend, right? So it does not make any sense at all. It makes very funny, right? So that even though it's grammatically correct, does not make any sense. Now a statement has a meaning. A statement has a meaning. So only when there is a relation between words. Similarly, there may exist other situations in our life where we use statements having meaning depending upon the situation. Let us observe the following examples. Right and left. Okay, you need to tell me about the difference between right and left. Now let's see this diagram which you see on that figure 1. In the figure 1, there's a person standing here at the position A, and there's another person standing at the position B. Now if the person 1 makes a statement that the house is at the right side, okay, it's right from his relativity. But when it is coming to the relativity of the person in the position B, for him the house is on the left side. So both are right in their own context, in their own relativity, they are correct. But when it comes to what exactly is true, both are true, but they are true with their relativity. So where they are. So let's take another example. Is day or night just now? Is it a day or night just now? It depends. Like if you are in Hyderabad, then it is a day for you, and if you are in New York at the same time, then it is a night for you. So for the person who's staying in Hyderabad, it's true, and for the person who's staying in New York, the truth changes. Okay, so this is something which will up and down. Can orientation like up and down be the same for all the persons at all times? It all depends again. Up to the following figure 2, and we'll see the positioning of the reed. Now in 2, if you see, for the position A, he seems to be on the top, and some person B seems to be on the bottom, right? And they are in a different position, but from their relative position, it would be like they are all in the right direction. Similarly, for person standing at the point C and D, the directions of up and down are not the same. They change the point of observation on the globe. So now here we have this figure 2, and by inverting the book. So if you just invert this book, children, like for B will be on the top and A will be on the down. If you just tilt the book. Now we know that Earth is a sphere. The upper direction of the vertical portion on the surface depends upon the place on which the Earth's surface where the vertical is drawn. So hence the notions up and down have no meanings unless the point on the Earth's surface to which they refer is defined. So we'll discuss the meaning of terms longer and shorter with a few examples here. So motion is relative, right? Like the terms right and left, up and down. So motion is always relative. Now let's take another example of like about the motion. So now we have figure 3 in which we follow the conversation between Srinu and Somesh, who stand beside a road as shown in the figure 3. Where are they standing, children? Somesh and Srinu are standing on the road. Now Srinu is saying, what is the state of motion of the tree? Okay. Somesh says, obviously it's in rest. It's not moving anywhere. What is the state of motion of the car? It is moving due east, right? So it's moving due east. Srinu, what is the state of the motion of the driver and the passenger in the car? They are also moving like the car. Now, how do you decide that the car, the passenger, and the driver are moving? With respect to us, the position of the car, the passenger, and the driver are changing with time. So they are in motion. For us, they are in motion. From the perspective of the Somesh and his friend, this car is in motion, driver is in motion, passenger is in motion. But what if we compare the relativity of driver and the passenger? Now, when it comes to driver, so for driver, is the passenger moving? No. Relative to the when we link the relativity between the driver and the passenger, there is no movement for these two people. Like they are still to each other. Right. So now the following the conversion of the driver and the passenger in the moving car. Okay. So in the moving car, now the driver. What is the state of motion of the tree? The passenger says it's moving due west because the car is moving towards east. It seems to them that the tree is moving due west. Driver, what is the state of motion of both the persons beside the road? They are also moving due to the east. And this is what is the state of motion? You are at rest. What is the state of the motion of the car? The car is also on the rest for them. Okay. So what answer may the passenger give to the driver? Discuss with your friends. Okay. So you just discuss this concept with your friends. Now let's do an activity, children, based on displacement, distance and displacement. So drawing path and distinguishing between distance and displacement. Take a ball and throw it into the air with some angle to the horizontal. Observe its path and draw it on the paper. Now, how does the ball go? If you are throwing it from point A, it goes up. If you're throwing it like this on an angle, it goes up and then falls down. So you have to just draw the curve in which it is moving. Now, what is displacement? Displacement is A to B. Okay, displacement is A to B. The shortest distance between between 2 points is the distance. It is the displacement. Now, what is the distance? Distance is a traveled path, like A to B, like this. So this is a distance. This is the displacement. Displacement is the shortest distance covered by object in a specified direction. Now observe the differentiation. So AB is the displacement and S is the distance. The S is the path here. So displacement is a vector to describe a physical situation. Some quantities are specified with magnitude as well as direction. Such a physical quantity is called vector. The physical quantity which does not require any directions for its specification is called scalar. So distance is a scalar. Distance is scalar. And displacement is vector. A vector can be represented as a directed line state segment. Its length indicates magnitude and arrow indicates its direction. So point A is called tail and point B is called head. Now the above example ASB shows the actual distance covered by an object, and AB is the displacement, which is straight line drawn from initial position to final position of the object. AB is called displacement vector. The SI unit of distance or displacement is meter, denoted by M. So whenever you see M, so what do you read it like? You should be reading it like meter, and if whenever you see km, you should read it as kilometers. So other units like kilometers, centimeters are also used to express the quantity. Now let's see the activity 2. So the activity 1, what did you do, children? You have actually thrown a ball in horizontally into the sky and just understood the difference between the distance and displacement. Okay, and drawing displacement vectors. Now here, if there is a displacement vectors, then a car moves along different paths as shown in figure 6.A and 6.B. So the points A and B are the initial and final position of the car. Now draw displacement vectors for two situations given below. Now here we have this. So this is A and B. So this is the movement of the car. So if it is like, so A to B, it's moving from A to B like this in the direction. So you just check the arrow mark, okay? And here also we have A to B. So what is the displacement? We need to draw the displacement of that. So how do you draw the displacement? Directly A to B. And here also A to B. That happens to be the displacement. So let's say if you have this in an example. Generally, the distance covered and displacement are time-dependent quantities. So think and discuss. What is the displacement of the body if it returns to the same point from where it is started? Given one example from our daily life. So when do the distance and magnitude of displacement become equal? So let's see that. Now, average speed and average velocity. A train named Telangana Express starts at 2 p.m. from Sirpur, Kagiznagar and reaches Hyderabad at 8 p.m. The same day as shown in the figure 7. Now here what happens? The distance covered by the train happens to be from Hyderabad to Kagiznagar and then from Kagiznagar back to Hyderabad. Okay, so draw the displacement vector from this Sirpur Kagiznagar to Kazipet and Kazipet to Hyderabad, and from Sirpur Kagiznagar to Hyderabad again. So let the distance of the entire trip from Sirpur Kagiznagar to Hyderabad be 300 kilometers. Okay, then if let's say we have this is the 300 kilometers, and what is the distance covered by the train in each hour? It is like 300 kilometers per hour into 6 hours. It will be like, so 300 kilometers is covered in 6 hours. So each hour per hour it is covering 50 kilometers, children. So can you say that the train has covered exactly 60 meters in each hour? Obviously the answer is no, because there may be some variations in the distance covered by the train each hour. So it might stop, it might go, it might become slow. So we take the average of distance covered by the train for each hour to decide its average speed. So the distance covered by an object in unit time is called average speed. So average speed is equal to total number of kilometers or meters, whatever it might be, total distance covered by the time taken to cover that. This is what is the so average speed is equal to total distance by time taken. Okay, and let the displacement of the trip in the above example be 120 kilometers due southwest. So what is the displacement in each hour? The displacement per hour is equal to 120 kilometers per 6 hours southwest. So 20 kilometers per hour southwest. The displacement of an object per unit time is called average velocity. So the average velocity is a vector that and is along the direction of displacement. So average velocity is equals to total displacement by time taken. So the quantities average speed and the average velocity explains the motion of a body in a given time interval. So they do not give any information about the motion of the particular body at an instant time. So think and discuss, children. What is the average speed of the car if it covers 200 kilometers in 5 hours? So it should be what? How should you calculate that? 200 by 5 will give you the average speed. So when does the average velocity become 0? You need to answer that in the comments. Okay. So a man used his car. The initial and final odometer readings are 4849 and 5549 respectively. So the journey time is 25 hours, children. So what is his average speed during the journey? Okay, so first you calculate the difference between this and this distance, and that whatever is the distance that is coming, divided by 25, so that you can get the average speed of it. Okay, so from here we continue in the next session. Have a great day, children.